Hi everybody, so I hope you've read this question and attempted it at least, and I'll go through it now. So the first thing we want to pick out is that the investment, the $3,000 is being invested for 15 years. You see, it's left in an account from 2021 to 2036. So if I go 2036, subtract 2021, that's 15 years, okay? Now, the next thing to note is that this is an annual compound interest rate. Okay, so it's like the account gains 8.97% at the end of each year. That's what it's like. Of course, the account earns and loses money every day in reality, but the average annual return is that. Okay, and so we're imagining that, and this is the past performance of this bundle of investments, this portfolio, and we're just going to assume that this average interest rate increases or continues into the future. So we invest $3,000 in 2021 and we multiply that by 1 plus, and then we turn this percent into a decimal. As a decimal, that is 0.0897. And so this is what would be in the account after 1 year, $3,269. Okay. And then after 2 years, as you know, with the compound interest formula, that would be to the power of 2. And we'd have 3,562 after 2 years, and so on. And after 3 years, we'd have 3,882, and so on, right? So after 15 years, we'd have what? $10,882.42. Okay. So that would be the answer to the nearest cent. Now, in reality, do you think for this problem, we should give the answer to the nearest cent? Why or why not? Or even the nearest dollar. Should we give it to the nearest dollar, the nearest $10, the nearest $100, or the nearest $1,000? Okay, so I think it makes sense to round to the nearest $1,000 because this is not a fixed interest rate. There's no guarantee that the college savings will have that interest rate each year. In fact, some years it might be negative 10%. Another year it could be negative 23%. Another year it could be 0%. Another year it could be 15%. Another year it could be 21%. The annual rate will fluctuate, right? So for me, it's smart to maybe round to perhaps the nearest $1,000, but definitely not the nearest cent or the nearest dollar. That would make no sense. So $11,000 would be the correct answer there, right? Now I'd like to show you what this looks like visually in Excel and the difference between earning money in an investment or putting money in a coffee can and burying it in your backyard or losing money, right? So our years go 0, 1, 2, right? So our years go up to 15 and imagine we're earning money. So in here we go equals 3,000 star parenthesis 1 plus 0.0897, right? But then it's to the power of the little hat, to the power of the years, this column here, enter, right? And I can click on that, take the little bottom right, hold down on the left click on my mouse and just drag that down there, right? And I can format the cells, by the way, to right click, format cells, and make by numbers 0 decimal places, right? So that shows that we start out with $3,000 and after 15 years we have this 10,882, right? And after 9 years is 6,500 and so on, right? What would happen if we just took our investment and left it in a coffee can? You would have $3,000 in year 0, and you would have 3,000 in year 1, and so on, right? And in fact, you can click on that, right click on the bottom right here, and just drag down like that. And that's what it looks like if you just leave your money in a coffee can for 15 years. You still have $3,000. Now, which is obviously not as good as this investment, but there's no guarantee in investments because they could go down, right? But call it savings account, over time probably will go up, right? Most likely, almost always. Now you could lose money, right? So what if you say lost 10% per year? That'd be like 1 minus 0.10 or 0.1 to the power of the years, right? I forgot my little star there, and I'll just drag this down. And this gray here would be if we lost money. So let's say we lost 10% every year in the investment. So by 15 years later, we'd only have $618, right? So that's a possibility. You could lose money, right? You're probably not going to. It's in reality, it's going to fluctuate up and down, right? It's going to fluctuate, but it should trend upwards. And the trick with all investments is to wait. Like if there is a dip and you're losing money, one of the tricks anyway is to just wait it out, and then there'll be good years, and then your money goes back up again, right? But in any case, that's what that would look like. Now notice that this blue line here is curved. That's a curved line. Okay, so that an exponential function is curved. Remember, that's an exponential, right? This orange is, what would we call the orange one? The orange line. It's flat, it's straight, so that would be a linear function, right? And it's actually a constant function. And then losing money is exponential decay. See how it kind of curves down gradually, right? And we could change that to like what happens if we were losing 0.05% a year, right? I should drag that down there. If we lost 5% a year, it would look like that. If our investment only gained an average of, let's say, 5% a year, then it would look like that, right? So we can play with this too.